All right, so before this lesson, I'd like for you to complete the how many shoppers on Black Friday activity. So if you haven't done that, then just go ahead and pause the video and then do that. All right, so in this activity, we are given a function that tells you at the number of shoppers who entered the store T hours after the sale began. And the sale begins at 4 a.m. So T equals 0 corresponds with 4 a.m. So A, or 1, asks us to write a function that gives the rate at which people enter the store. And so we take the function that tells you the number of shoppers and find the derivative, and that is the function that gives the rate at which people enter the store. All right, and then 2 asks us to find at what rate the shoppers are entering at 7 a.m. Well, 7 a.m. is 3 hours, so it's 4 a.m. So 7 a.m. is going to correspond with 3, with T equals 3. All right, so I just plugged 3 in, and I just used the calculator, and I got 486. And then the units is going to be, since it's a rate, is 486 people per hour. All right, and then 3, we're given a rate. So this is different than S. S was a function that gave the number of shoppers. 3L is a function that gives the rate at which people leave the store. So L is already a rate, so it's a little different, but we can still work with it. So A asks at what rate are the shoppers leaving at 7 a.m. So we don't have to find a derivative of that. It's already a rate, so we just plug in that 3, and we get 120 people per hour. All right, B asks, is the number of shoppers in the store increasing or decreasing at 7 a.m.? So we just compare the rate that shoppers are entering and the rate shoppers are leaving to determine that would be increasing, because shoppers are entering faster than they are leaving. Okay, and then 4 asks us to write a function h of x that gives the rate at which the number of people in the store is changing. So that's where we take the rate at which people are entering, which we'll call rate in, and subtract the rate at which people are leaving, which is rate out. All right, so rate in was S prime, rate out is L. All right, so then I used my calculator to get some points. And then a positive value for H is going to mean that the rate entering is greater than the rate leaving, and the number of shoppers is increasing. And the negative is going to be the opposite. The rate entering is less than the rate leaving, and the shoppers number is decreasing. And then for 6, at what time, if any, is the rate at which people enter the store the same as the rate at which people exit the store? So I want to put this in the calculator and show you all. All right, so and I'm going to tell you in a second, a good way to do these rate in, rate out problems is to type rate in into Y1. Oops. All right, and then the exit or the leaving function, type in rate out function, type into Y2. All right, and then Y3 is going to be Y1 rate in minus Y2, which is rate out. Okay. All right, now I only want to graph my h function, which is rate in minus rate out, the y3. So I'm going to turn those others off. And I want it to kind of match what I had in the graph. So the x went from 0 to 12. And then the y went from negative 400 to 400. Now, the scale doesn't really matter, but I'm just going to make it match what I have on the paper. There it is. All right. So what we want to find, if we want to find where the rate at which people enter the store is the same as the rate at which people leave the store, that's going to be when that h function, which is this one, is 0. And that's happening at the 0. So what we'll do is calculate the 0. So second trace 0. And we'll hit enter on the left. And we'll hit enter on the right. And our calculator can figure that out for us. So when t is 5.545, those two rates are equal. So we'll write it out, which I already did. And so 5.545 hours after 4 a.m. Correlates to approximately 9:32 a.m. Which is still earlier than I want to get up and go shopping. Okay, so let's look at this important ideas. So y prime of t is going to always represent the rate of change of y of t. All right. And when y prime of t is 0, whatever that y context is not changing. And when we were talking about particles in motion, we would say that that particle is at rest. It's the same idea. It's a different type of context. So today our text is going to be other than motion. All right. And then if that y prime of t is greater than 0, whatever that y context is increasing. And then if the y prime of t is less than 0, the y context is decreasing. Okay. And something we are going to do today is use our calculator to do these problems. And so I just showed you how to do it. So when you have rate in, rate out problems, which they love to put on the AP test. So they have put banana problems, they have put potato problems, they have put water, coffee dripping problems. So they're on there. So Y1 is going to be rate in, Y2 is going to be rate out. And then y3 is going to be y1 minus y2. And then you can use that to represent the overall changing of whatever the y context is. Okay, so let's do some examples. And some of these I think are going to feel familiar to what we've been doing the last few days. This might be worded a little differently. So on example 1, Paige has taken an initial dose of prescription medication. The amount of medication in milligrams in Paige's bloodstream after t hours is given by that function m of t. What is the instantaneous rate of change of the medicine in her body 2 hours after 2 hours? Sorry. All right. So when we're asked to find the instantaneous rate of change, we're asked to find the derivative. So we want m prime of 2. Now we could do this by hand because it's just a chain rule problem and it wouldn't be that difficult, but because we have to use a calculator to figure out what e to some power is, let's just go ahead and let it be a calculator problem. All right, now we don't need rate in, rate out on this one, so I'm just going to go to y1. I'm going to type in my function. All right, and then I'll quit out of there. And then I'll let my calculator find the derivative of the function that we typed into y1 when x or t technically is 2. All right, there it is. So don't forget, and I know I've told you this a lot, we want to be accurate to 3 decimal places. And we do want to use appropriate units. And so don't forget the original M of T was the amount of medication in milligrams, and T is in hours, so the derivative should be milligrams per hour. All right, and it doesn't tell us to do this, but I'll just do it out loud. If we wanted to explain the meaning, we would say at T equals 2 hours, the amount of medication in Paige's bloodstream is decreasing at a rate of 3.230 milligrams per hour. All right, so for 2, the amount of water in a tank is given by that volume, where T is in minutes and V of T is in gallons. Is the volume of water in the tank increasing or decreasing at 5 minutes? So this is a polynomial. We can do all of this without a calculator at all. So let's do that. So we want to find, if the volume is increasing or decreasing, we need to find the derivative, the rate at which it is changing. So we're just going to find the derivative using the power rule, and then we're going to plug in 5. All right, so we get 4. This is technically 4 gallons per minute. And it says to explain. Well, first, we need to decide if this is in the tank, water in the tank is increasing or decreasing. So because 4 is a positive number, the water in the tank is increasing. So we would say that the volume is increasing at T equals 5 because B prime of T, B prime of 5 is greater than 0. That is perfect explanation right there, perfectly fine. Okay. For B, is the volume of water in the tank changing faster at T equals 1 or T equals 5? So we already know how fast the water is changing at T equals 5 minutes. So we'll just take our V prime and plug in 1, and we get negative 12 gallons per minute. So you have to think about which is a faster change, changing at 4 gallons per minute or changing at negative 12 gallons per minute. And the answer is negative 12. So it's decreasing at a rate of 12 gallons per minute. The other one's increasing at a rate of 4 gallons per minute. So 12 obviously is larger than 4. So don't let the positive and negative get you too confused. That just tells you increasing or decreasing. The rate is the 12 and the 4. So we would say the volume is changing faster at T equals 1 because negative 12 gallons per minute is a faster rate of change than 4 gallons per minute. All right, for 2, must there be a time when the volume of water in the tank is not changing? What does this sound like? To me, it sounds like the intermediate value theorem, because it is. So we're going to review that. It's so awesome to review it throughout the year. So if we use it and use it and use it, you'll remember it at the end of the year. So the volume of the water in the tank is not changing when V prime of T is 0. All right, so let's remember the intermediate value theorem. So first condition is that the function must be continuous for the intermediate value theorem to be applicable. Our function v prime of t is a polynomial function, and polynomial functions are continuous everywhere. So we would just kind of make a note of that. V prime of t is a polynomial function. Therefore, v prime of t is continuous everywhere. Okay. The next thing we do is find the value of v prime of t at the endpoints. Now we aren't given an interval here, but there's two things that we know, and that's v prime of 1 and v prime of 5. So we're going to let those be our endpoints. So v prime of 1 is -12. V prime of 5 is 4. So what we're looking for is to see if 0 falls in between those, and it does. So v prime of 1 is less than 0 is less than v prime of 5. All right, so this one checks all the boxes. So we would write our statement that because v prime of t is continuous, and let's just let our interval be from 1 to 5, and v prime of 1 is less than 0 is less than v prime of 5, the intermediate value theorem guarantees there is some time t such that v prime of t equals 0, thus the volume of water is not changing. All right, it feels good to remember that. Okay, a couple more. So these are rate in, rate out. Both of these are. So on 3, snow accumulates on Miss Montgomery's driveway at a rate of f of t equals 7t e to the cosine of t cubic feet per hour, where t is measured in hours since midnight. The rate g in cubic feet per hour at which Miss Montgomery removes snow from the driveway t hours after midnight is modeled by that piecewise function. So A asks, at what time does Miss Montgomery start removing snow? All right, so from 0 t equals 0 to 6, the value of the removal function is 0. So she doesn't start removing snow until 6 a.m. right there. All right, and then B, find the rate of change of the volume of snow on Miss Montgomery's driveway at 8 a.m. Okay, so we need to write a function that is the rate of change of volume of snow. And this is going to be a rate in minus rate out function. Let's just call it V of t for volume. So the rate in function is f of t. F of t is already a rate. The rate out function is g of t, right? It is also a rate. Both of those rates are in cubic feet per hour, sorry, which means that we're good just subtracting them from each other to give the rate of change of the volume of snow in the driveway. All right, so what we would want to do is go ahead and find V of 8. So it's going to be F of 8 minus G of 8. All right, and I'm sorry I didn't give you enough room, but When I put 8 into the f function, it's 7 times 8 e to the cosine of 8. And then when I put 8 into the piecewise function, 8 is going to fall in this piece right here. So f g of 8 is 108. All right. And then you can just get that from the calculator and round to 3 decimal places. That's going to be negative 59.583 feet per cubic feet per hour. All right, so it looks like she's getting some snow off at that time. She's shoveling faster than the snow is falling. All right, and then 4, we have a penguin problem. The penguin population on the island is modeled by a differential function p of t for t is between 0 and 40 years. There are 100,000 penguins on the island at time t equals 0. The birth rate of penguins is modeled by this b function. The death rate is modeled by this d function. And both of those are in penguins per year. They're both rates already. All right, is the penguin population increasing or decreasing at t equals 5 years? Now this sentence right here about the number of penguins, we actually don't need yet. When we get through the year, we talk about a whole bunch of different things. We will use that to answer different questions. We don't need that right now for this particular question. All right, so this penguin population, we want to know if it's increasing or decreasing. So this is, we'll call the penguin population rate P of t. And it's going to be a rate in minus a rate out. So the birth rate is the rate in, the death rate is the rate out. All right, so let's just go to the calculator. All right, so I'm going to go ahead and put my birth rate function into y1. All right, and then I'll put my death rate into y2. And then the y3 function is going to be my rate in minus my rate out. And that function is going to give you how the population is changing, the penguin population is changing over time, how fast. All right, and we want to know that if the penguin population is increasing or decreasing at 5 years. And there's different things we can do. We put that one that gives the rate the penguin population is changing into y3. So what I'm going to do is just go back to my home screen and I'm going to choose y3. That's where the function is that I want to know, and put in 5 in parentheses. So that's like y3 of 5. We're putting 5 into y3. Okay. And that gives us 937.678 penguins per year. Let me just double check that because I'm not getting the same thing I got before. Oh, sorry, yeah, I am. My bad, that's right. Okay, so that's going to be penguins per year. All right, and then we want to know if that's increasing or decreasing, and it's definitely increasing because that is a positive rate. So the penguin population is increasing at t=5 years because p of 5 is greater than 0. Right, for your assignment today, I have some pulled apart AP free response questions from previous years. We're not ready to do a full AP question about rate in, rate out because we just haven't learned enough calculus to do it. So for each one, I think there's just like 2 parts, an A and a B or a B and a C, that I want you guys to do.